So let's take a look at some examples of this now. If we look at our first set of examples, all of our examples are what we call numerical expressions. So notice, in the numerical expressions there are no variables, and all of our final answers end up in becoming a number. So it's very important that we understand that when we start with numerical expressions, we need to finish this all the way to the end with a number, and we may have to use our calculator to do that. So you can see in part A, we're using the product of the power property, where we multiply the two together. In part B, we do the same process over a fraction. Part C, if you notice, this can sometimes be confusing. Our base is the same, it is -5, or you could actually raise the -5 to the -6 power or to the -4 power and then go from there. There is one little typo that I would like to fix, is that this -5 down here should actually be in parentheses to be technically correct. So, and you can see how each of those was finished out. So what I'd like you to do right now is just simply pause the video, and sample problem 1 has parts A, B, and C for you to work. So go ahead and try that at this time. Okay, so if we're simply using each of our properties, and we look at our first one, it's a power of a power property, so the base is 3. And so we're going to be multiplying the 4 times the 2, which is going to give us 3 to the 8th power. And of course, if we punch this into our calculator, we get 3 raised to the 8th power, and that's going to give us a value of 6,561. And so you can just write that as your final answer and box that. Please do not leave your final answer as 3 to the 8th power. That will happen with variables, but if we are working with numerical expressions, you need to be sure to work it down to a numerical answer, final answer. So part B, similar property except with a quotient or a fraction, and so we need to apply the 3 to each part. So the top is raised to the 3rd power, and then the denominator is raised to the 3rd power. And then we will do each of these calculations separately, which is 125 over 512. And of course, if you needed a calculator to do that, that is fine at this point in time. Later on in this unit, we will actually be learning our cubes and our fourths and our fifths as we move along. Lastly, we have a multiplication problem that has the same base, and although this base is a -2, it is the same in both cases, so we can actually add together the exponents. So -2 in parentheses, and we're going to add the -3 plus the 9, which gives us -2 to the 6th power. And if I use my calculator correctly and keep that -2 in parentheses, the final answer would be 64. So, very important that you know how to use your calculator in raising powers and using the caret sign to get your final answers. Now we're going to go into problems that have algebraic expressions, and so in this case we are dealing with variables, and so it's very important that you know where to stop and how to separate your variables. If you're working with variables, they have to have the same base to use the property, so you cannot combine an R and S in part A. You can only work with the 2 R's, you can only work with the S's to come up with the final answer. Same thing in B. In B, we have numbers and variables, okay, so it's still algebraic if we have a coefficient. And then, of course, you can only combine numbers together, and you can only combine like variables together with these properties. So if you look at sample problem number 2, we are working with algebraic expressions. So go ahead and pause the video and try part A and B for sample problem number 2. Okay. So in part A, we have a pretty straightforward problem. We need to distribute the power of 3 to each part inside the parentheses, and of course that's going to give us a power of a power. So A is going to be 2 times 3, and then of course B is going to be negative 3 times 3, which is going to give me A to the 6th over B to the negative 9. Now this is where we need to make sure that all of our final answers do not have any negative exponents. So technically what we've got going on here is this. We've got A to the 6th over 1, and we have 1 over B to the negative 9. Now, I know that's a funny way of writing what we had before, but it gives us a clearer picture of how to use that negative exponent. And if you recall back from our previous properties, if we have a negative exponent, we can just flip the numerator and denominator and make the exponent a positive value. So that's what we're going to do in this case. A to the 6th is over 1, which it's understood, we don't need to write that, but the B to the negative 9 needs to be flipped with its 1, and so then that gives us B to the ninth power. I'll try to write that a little bit better. And of course it's unnecessary for us to put the multiplication sign between them, and it's also unnecessary for us to write that over 1, and our final answer is A to the 6th, B to the 9th. Now, if you become more comfortable with this, it is perfectly acceptable for you to just take this value or variable and just move it up top, because that's in effect what you're doing. And you can just switch the negative exponent with this variable from top to bottom or bottom to top, whichever direction it needs to go. So let's look at part B. Part B brings us an interesting look at this. In the first part, we have a negative y, but the remaining variables in the problem are all positive y's. So the negative y is technically not the same base as all of the positive y's, and we want it to be the same negative base. So we have to take this and actually factor out that negative at some point. Now before I do that, I actually need to do the power property here and distribute that 5 inside the parentheses. So when I do that, I get negative y to the 10th power, and then of course we have y squared and then y to the negative 12th power. Now keep in mind, this negative y to the 10th power is different than having y to a negative exponent. The negative exponent will clearly need to come down, but the negative y does not affect the exponent itself. Now, here we have two y values that are the same base. But because of this negative exponent with negative y to the 10th, a negative base, I need to get that negative out of there. So what I'm going to do is I'm actually going to factor out a negative 1. Now when I factor out that negative 1, what's left over is y to the 10th power, and then y to the 2nd, and then of course y to the negative 12. Now, before I go move that negative exponent, y negative 12, to the bottom, I want to go ahead and do my consolidation first. And so since each one of these now has a similar base, I can put those together, and then I'm going to add the exponents. So 10 plus 2 minus 12, or plus a negative 12, will then give me y to the 0 power. So 10 plus 2 is 12, 12 minus 12 is 0. And if we recall from our properties earlier on, y to the 0 power, or anything to the 0 power, is just equal to 1, which gives me negative 1 times 1, which is going to give me negative 1 as a final answer. Now, there are so many different ways that you could have combined all of these properties together. That is not the only way to work that particular problem. But what I think you'll find as in Algebra 2, as we go into much bigger and bigger expansions and consolidations of exponents, that there's multiple ways for you to come up with the same answer. So no way is or order is necessarily the correct way, but we all do need to finish at the same place. Now, on the next page, we're going to give you a couple more samples to work, sample C and D, and these are getting a little bit more lengthy, and they're requiring you to use the properties instead of expanding, and I'll give you an example of that after you finish that. So go ahead and pause the video and work C and D at this point. Okay, now I'm going to work C, and I'm going to work part C in two different phases. So just bear with me. I'm going to erase some of this in a second, but I want to show you the two different methods that when you start getting these longer problems that they can kind of become a little bit confusing, how you could work them. So I'm going to do the first one using my properties in the correct manner. First and foremost, this 2 has to be distributed to both parts. So I'm going to get x squared, and then 2 times 2 is y to the 4th. And of course I get x to the 3rd, and then y to the negative 1. Now, here's the first thing you need to recognize. You're multiplying each set of variables on the top and the bottom, but we only want to work with like terms. So technically what's happening here is you can break this apart and work strictly with the x's first, and then you can work strictly with the y's. So if I'm working with the x's, I have x squared divided by x to the 3rd, and of course that's going to be subtraction. Then, and I'll use a different color here, I can do the y parts as well. So 4 minus, and since the exponent on the bottom is already a negative, we need to subtract the negative value. And this is going to leave me x to the negative 1, y to the positive 5. Now, if you recall, we need to take this variable with the negative exponent and we need to bring it down underneath. So our final answer is going to be y to the 5th left on top and x to the 1st on bottom, and of course the first power is understood. Now, if we wanted to take this and look at it in a different format, think of it this way. We technically have x times y times y times y times y all over x times x times x, and then we have this situation y to the negative 1. Now it's going to be very hard to represent y to the negative 1, but we know that from the standpoint, if we want to get a positive value, we actually need to take this y to the negative 1 and move it back up. So it actually gives us a 5th y up on top. Now, if we notice here, we recognize that like terms cancel out. So that cancels and that cancels. And then we can rewrite what we have here. So we have 1, 2, 3, 4, 5 y's on top. And we have 1 x left on bottom. And of course, that provides us the same answers we got using the properties. Now, let me make a note about this. That may look like a real simple, easy way to work these problems and something that you might want to try to do. But I'm going to tell you at this point that as we get deeper into this unit, if you try to work it out the second method that I just showed you, you will not be able to fit it all on one page because the problems just get too long and cumbersome, and you have variables and exponents going everywhere. So be comfortable with the properties and how to use them appropriately. So at this point, I'm just going to erase this second method so that I can work set D. Okay, and then so for part D, we have an R and then an S squared. And then of course I've got to distribute this 3 to each part in here, so it's r to the 3rd, and that's going to be x to the negative 3. And you could, if you wanted, move the s to the negative 3 up and then add the exponents, or you could simply subtract and understand that this is r to the first power. That's an understood value. So that's 1 minus 3. And then, of course, s is 2 minus a negative 3. And so I'm left with r to the negative 2 times s to the 5th. And, of course, this isn't understood to be over 1. That's understood to be over 1. The negative exponent needs to flip or change places with its denominator to make it positive. And so my final answer is going to be x to the 5th and r to the 2nd, and that is the final simplified version. Okay, so this has been a good review of properties of exponents. This is going to be an extremely important section leading into the unit as we add on to these various properties and the way that they are used.